Now, what I'm going to do in ACL is take the data file that has a description field. It's a general ledger description, about 500,000 records of real data, 2013 versus 2014. That's all, all we're doing. It's about 250,000 records per year, 500,000 records. And what I do is I split up the word field into 10 words. That's done in ACL. I kind of then do some summaries and analysis, which are then fed to Excel. And in Excel, notice the summaries here. Notice how all of these graphs and charts are very much in alignment as you look across from A to Z, from left to right in the graph, and then outward, kind of back here, you can see A to Z showing up in the first word, the second, the third. Remember, we had 10 words in the description. I've now split it up into the 10 words, A to Z. And a comparison now, 13 versus 14. Remember, 250,000 records or so, which is over on the right-hand side. Notice the right-hand side, we had about 250,000 records per year, and you can kind of see what letters are driving that, an A, a C, and again, it's a bit of a fingerprint. I mean, it really does look very similar per year, and also across the time frames. So, but why do I care about this? Well, there is a something called the Caesar cipher. You can look it up here at this YouTube link, and it's on Khan Academy, and there is a Benford law to letters. And so, why do we care about summarizing on words? Well, it's a really quick way of understanding the entire population. I don't care if it's general ledger, T&E, accounts payable, payroll. You could very quickly get a rich textual reference around what is that transaction. And it's much better than digital analysis, which I'm going to show you. You can then very quickly get to key questions about the data and really understanding the business. You could say to them, payroll, accrual, interface, these seem to be the big things that you're doing. And they'll say, yeah, like out of my 250,000 records, I'm spending most of my time there. And again, this is just coming from letter analytics. It works like a DNA, and it allows you to very quickly get to meaningful questions in seconds, as we'll show you. I think you also get some more assurance around getting more comfort around what's going on in that business process beyond just the digital analysis, but also getting more of a word on the street. You'll understand what are the words being used, and therefore kind of like what's on the word on the street. What are they saying in their textual type references? I think there's some great comfort that not only are you now looking at numbers as well, but also looking at the letters associated. So in more detail, as you can see on this slide, I found it really interesting that adjustment had and gift card had literally the same number of words in 13 and 14. Like the actual possibility of that happening is like unbelievable, real data, and yet that happens. But you can kind of see how some of them do go up a little bit, some double, like reserve double. Does that mean that reserves have doubled in activity and therefore we should look more into that? So these are things to take a look for, and now we'll get into the data itself and look more at how this works. So let's go back to something we're all comfortable with, Benford's Law. I summarized a variety of data which is here, and I think it was, maybe, 100 or 40,000 rows. And what I then did was I summarized that down and said, well, how many ones do I have and twos? And, Benford Law. And what is Benford's Law? And, here, that's Benford's Law here, 30% of one and 17% of two. And here's my difference. That's what I really care about, the difference. Notice how the difference is very slight, except for the number 5. So let's kind of go and look at the number 5. So here is every value summarized in my data, high to low. So you see 50, etc. I'm going to click on 5. Now I have every 5 that showed up and the count over here on the right hand side. And I can see there is actually quite frankly, a very nice parallel of 2013-14, with the exception maybe of a few small ones that are kind of ramping up or something. But again, it allows you very quickly to get into digital analysis and to understand some of the deviations and understand, kind of why is 5 happening a lot. Well, I can very quickly, through a few pivot tables, get to that point and show you the reason why. These are the reasons why. It's sort of outside of Benford law. So keep that concept in mind. That is just the numbers. Numbers are nice, but again, it doesn't really give you a full picture of what you're looking for. So let's go to ACL. In ACL, I built a script that will do some word summary, and it's a lot of data. It's hundreds of lines of code. Let's not go through that right now. Let's just say this. I did a research project with AuditNet, and we had 500 people tell us their top words that they care about. And we found gift and bribe and correct and etc. to be some of these top words. I looked at every one where people said 3 or more said, let's look at that. It's a weird kind of odd word. Okay, so I pulled that. There was about 316 of those words. I then searched through my key data file, and also I think this is the final results of that, where it kind of has the description over here, but then it has kind of where, what word showed up and all that. We're going to look at this in a much better way in a second. I also did a summary, though, of all of the keywords in the data. So that way, now I'm kind of looking at every word, and not only the first letter of that word, the year that it showed up, how many times it showed up in that year, and what word order. Like, is it the first word, the second word, the third word? Now I can classify on the word order and get to a count of how many times, words showed up in each one. And what I found really interesting is notice how, you obviously have more first words than second and third and fourth, and it really does follow that pattern, obviously. So, there is some consistency to the data. And now that I have that in ACL and I've run these scripts, the script takes about 3 minutes to run on 500,000 records, gives you all these nice results, which look way cooler in Excel. And so this is the data from ACL that's been fed into Excel. And this is a pivot table of the data. This is now every letter. Now, in looking at this is in our summary here. These are all of the unique words that are being used. And as you can see here, there are about 63,000 unique words being used in each one of these categories. So it's in the first position, second position, etc. And again, when we say unique words, it's more of a count of what we're looking at. So the word accrual would be one word, and then accruals would be a second word in this pivot. Now, I kind of find, from a fingerprint point of view, this is where you see it, because the count is so, it really kind of takes out a lot of the variation, as you'll see in a second, and it flattens things, and it makes it where, quite frankly, in any given month, or in this case year, as you look across the words, the letter A should be used pretty evenly, and the letter B and C and whatever. And you do see some spikes, and one particular spike is in the letter P. So you could kind of see that really quickly, and that's odd. It really should be kind of level and even when you think about it. So in looking at the P words, which are, kind of sorted high to low, I then pivot table that here. And this is kind of, high to low, just showing you the word. It's only a count of that word, but it kind of gives you all of those P words, and it allows you to kind of drill down and learn more about why do we have so many P words. I'm looking in the word order of basically the sixth word in that sequence of that description. Now, if I look at all of them, I can do that as well. What's interesting is the word project and payroll. Payroll, was kind of a big one that would show up in this. Is essentially showing up about 10 times. So it's showing up in each one of the words. So it's in the first word, second word, third word, and hence we have 10. And so as you can see that. So it's kind of interesting that one is showing up quite as much. Other ones are showing up less, but this is something where it's a great tool in allowing you to see very quickly the spike, which would be the 6 that we had from before when you looked at that graph, and why are there so many P's, and also from a total point of view, and just kind of seeing all the words. Jumping over to the word occurrences, we can see that the 63,000 unique words actually turns into about 2.1 million words. Now, in looking at the actual data itself, we find that the trending is a lot looser. I mean, the fingerprint that we had before, when we took a look at that actual graph, I feel is a lot tighter when you look at each letter than when you're looking at the total word occurrences. Now, we have 2.1 million, so we have some letters in like the first word that are showing up 70,000 times and, such. And in looking at some of the trends, one of the things that jumps out is the letter G. It starts out heavy and then it dies. And you can see that in the pivot even, where you can kind of see how you have 54,000 occurrences of basically the word GL/PR, I guess payroll. And in looking at that, you have that happen there, but it never happens in any other word, not in the second, third, fourth, etc. There are other words like that. Really interesting trend, but also it shows, just looking at a high level, it really shows it's just one of the top things to look at. So, you may as well look at that, and it's not something that's like an even trend like some of the other letters in the data. Now, also looking at this, you'll see that there's a spike. It's a little hard to see, so I got to zoom in heavily and kind of drill down to this. But you'll notice the letter, number one, a lot of the letters are very consistent. But one thing you'll notice is the letter C jumps from about 9,000 to 15,000. So I took a look at just the first word, 2014, letter C. That's here, that data. And what we can then do is I sorted that high to low and just try to look at some of the top words which are here, and is something that you could look at to try to understand why the jump. And since everything trends pretty nicely when you look at the graph, what are some of the things that really jump out in that graph that you can take a look at and go trend into? And one of the ways of doing that is just to take a look at each letter and look at that with a slicer here and take a look at, just go through A through whatever. And again, letter G, very, very strange. Now, I wanted to go back to something that we talked about a little bit before, where we aligned keywords to data and to identify weird words like account and adjustment and alcohol, etc., those types of words. And if I take the same data summary approach now and do my analysis, I have a fingerprint now of keyword usage, which again could be done over, say, a 3-year period or such. Now I'm going to look at the letter analysis, and this is just the word occurrences, and they're not that many. They're just like maybe a few thousand, because we're only looking at 316 words showing up across the data. Now you can see some of the letters that kick out. I kind of liked seeing some of the ones like this 104 over here that seem to just jump out of nowhere, where there's quite a bit of others that hardly are happening. And then we have, like, in the 10th word or in the 8th word, the letter B is spiking up. So it's really hard, a lot easier to see the spikes in the keyword analysis as it is in the entire word analysis. Now, looking at the actual data itself, I realized that A, C, B, and R were kind of words that were happening quite a bit. And one way to see that just quickly here is I can click on A, B, C, and R. and then go back to this word summary. And again, you can take a look and see some pretty interesting trends, but also some high numbers in some of the cases. So taking a look at that, I realized that about 93% of A, B, and C and R is being represented in just these numbers here. It's like it makes up almost everything. And there are just a few words that are really driving kind of the keyword usage at this company. Again, these are the words at the left. What I also noticed was that the ones in red are ones that are changing quite a bit. A lot of the others are actually pretty consistent, but these are ones that will change quite a bit. So this analysis not only works for entire word summaries, but could be done for just selected words, as we did here. In summary, textual analytics works really quickly so that you can get this perspective of your business process data, and it works so quickly you can almost work in real time with the client. You don't have to prep. You can look for deviations over a 1-year period, but I even think a 3-year moving average would work better in relation to that current period. If digital analysis, Benford's law, is latitude, textual analytics is longitude, and you really need both in order to zero in on what you're looking for. Text is just far richer in business value, helping to provide a picture of what's really going on in that business process than you could ever find out from digit theory. Remember that the unique word chart that we had, the count, provided more of a normalized view of the activity, and spikes are going to be seen in that really quickly. The MCI fraud was something where just 2 words were being used over and over again. That's going to catch up in something like the count, but especially in the word occurrences, where something now you're going to find a more dynamic chart there, but yet it's something that's going to provide you a better perspective of what are the actual usage of words within the business process. And why not use another approach like Benford's law to look at all of the data quickly to get that comfort when you know that you're relying on natural laws of letter usage? And now you're looking at the unique data to understand how does it apply to our situation in our business.